Cool. I think we're live. Hi,
Yes.
everybody. Hi, Loan.
Hello, everyone. Hello, Maxime. Thanks for having me.
Well, it's a pleasure, of course, always. It's a pleasure to have some guests, people outside from MongoDB and working a lot
Yeah,
with MongoDB. So, no, it's going to be
well,
great, and we're going to have some fun today.
I'm very
Uh,
excited about it.
we're going to have some fun. We're going to build some very cool tech. We're going to use AWS. We're going to use MongoDB Atlas. We're going to put some stuff in production. Well, at least it's going to look like something something that looks like something ready for production. I think we can say something like this, but it's going to be very, very close, right? So yeah, you're going to see that. We're going to discuss a lot of things today. We're going to touch a lot of different tech. We're going to touch AWS. We're going to touch Kubernetes. We're going to touch Helm. We're going to touch like many services in AWS services. We're going to do like SSL certificates. We're going to do Docker repositories. We're going to do load balancing. We're going to do, of course, the EKS, what's the name for this? The Elastic Kubernetes Service, right? From
That's
AWS. We're going to build the MongoDB Atlas Cluster as well. We're going to have a discussion about MongoDB Atlas itself, what it does and how it works. And we're going to do some, of course, tuning in there. We're going to use also the VPC pairing between our Kubernetes cluster in AWS and our MongoDB Atlas cluster in Atlas, of course. So yeah, let's. We're going to start very soon. We're waiting for a few people to join. I see we already have a few people logging in. Of course, if you have like any questions during the stream, please feel free to ask any questions in the chat, either from Twitch or from YouTube. We are live on both platforms. So yeah, please feel free to ask us any questions related to MongoDB or of course Open Commerce, because today that's what we are going to deploy with MongoDB. Loan, can you tell us a bit more about Open Commerce and what it is? Some the big lines and what you do as well. Like I think we should do some presentation.
Sure. So first of all, it's a pleasure to be here and an honor to be presenting on the Twitch and YouTube channels of MongoDB. It's I've been looking at these streams for a while now. It's pretty cool to be on the other side. So I'm the founder of Outgrow. We're a dev shop focused on next generation e-commerce projects. So we build projects for clients. We specifically specialize in e-commerce, and we use, for most of our projects, we use a technology called Open Commerce, which is an open source e-commerce API built on Node.js and GraphQL. It's pretty cool, actually. So if you've worked on e-commerce projects in the past using some things like Magento, for example, it's completely different in terms of paradigm, in terms of the way that it works, compared to just being a huge monolith that has a team system, etc. If you've already done e-commerce before, this is really just a GraphQL Node.js API that you tap into with your own storefront and your own admin UI that you can build custom. It's just an API. You can do whatever you want with it. And the best thing of all is that it uses MongoDB for the database. So it's an amazing piece of software. I think now been out there for 5 to 6 years, something like this. It's recently become a MailChimp project, which I'm very excited about. And generally speaking, it's I just love it. Been doing that for a few years now, so let's dive into it. I'm really excited to show you guys what it's all about. Actually, I had some slides here, but looks like Chrome needs to be restarted for for my screen to be shared. So Maxime, if you wanna show us the slides, or we can just do without it. I've really I've really gone through the Open Commerce in a nutshell and what it is and what it does. So I think we're all good there. That's what the slides we're covering. If you wanna show us the slides,
I can bring them up here.
Yep. Sorry about that. New version of macOS. Actually, they have this permission system. You have to restart apps to give them permission to share.
Well, actually, we should have shared this slide, from the beginning, I guess. But
yes,
yeah.
sir. All right. So
that's the two of us. You can reach out to us on Twitter. I'm M Beugnet on Twitter, and Loan is Loan. How do you pronounce your name in English? I'm curious about that.
Well, in French we say Laux. Some people say Laux in English. Whatever. I just accept everything, but it's Laux by default. Yeah.
All right. So yeah, so you can reach out to him as well on Twitter if you have any questions about Reaction Open Commerce, not Reaction Commerce anymore. The name changed, new font, new ownership. So yeah, it's complicated for me to adjust. But yeah, so I'm going to pass your slide and you can keep talking.
Yep. So as I said, MailChimp Open Commerce, open source, and for those of you who just joined the stream, I'm just going to go over it really quickly. Open source e-commerce API, everything that you can do with something like Magento, where you have this kind of, I wouldn't say it's legacy. It's still very much very much appropriate for a lot of projects, but it's a different mindset. It's a different paradigm, right? So instead of having just one monolith like Magento, like Shopify, like so many other e-commerce platforms, you will have a GraphQL API that you can tap into with your own user interfaces. You can have as I'll show later, you can have a web storefront, you can have a mobile app, you can have many things connected to it, and you can just build your own UIs from scratch, and you get an amazing developer-focused GraphQL API, and it's open source. So we can move to the next slide. As I said, there's a few points that I've already said. It's Node.js e-commerce API. It's open source under GPL license, which is amazing. I love it. 100% GraphQL and auto-documented, which is amazing for developers. So if you've already worked with GraphQL, you know that there is something called schema introspection, which for developers, when you're in the GraphQL playground, which is where you can go and try commands on your API and kind of sketch commands, etc., do drafts. There is the schema is self-documented, so every GraphQL mutation and query and every variable, etc., has a documentation built into it. So within your query editor in the playground, the GraphQL playground, everything is documented. So if you're wondering, like how does this command work? How does this mutation or query work? What do I need in terms of, what do I need to pass it in terms of arguments, etc.? It's all auto-documented. You don't have to go and look at a separate doc site. Obviously, there is one if you need it. But you can just be in your GraphQL playground and you have the documentation right there. So that's the perks of GraphQL. Some projects use that, some projects don't. Open Commerce does, so it's amazing. The plugin system, there's a bunch of ways that you can modify, customize Open Commerce. So there's a pretty flexible plugin API that uses NPM packages. So when you want to build, if you've already built e-commerce websites with Magento, with Shopify, etc., you probably have already built plugins or apps or however they call them on the ecosystem that you worked on. And Open Commerce uses NPM packages, and you can have your own private repo if you don't want to share the code, or if you want to keep them open source, then you just publish them on NPM and voila. So pretty cool, very developer focused, and a big departure from the standard typical e-commerce platforms that you see out there, especially the ones that were built in the started
60s.
Yeah, that date back from the early 2000s, I would say. So not to name names. And as I said, it's built on MongoDB, so it's amazing. It's object. It's thought for an object database first, right? It's not like it was built for MySQL and then moved to MongoDB, but kept the old paradigm, etc. No, everything is thought for MongoDB. So the way that the data is structured, etc., is really thought in a object first manner, which is amazing. So we have someone asking on the chat, does it have also a REST API? It doesn't. I would say they've taken kind of they've taken the side of just going all in on GraphQL, because that's kind of the future of APIs, if you ask me. So it doesn't have a REST API, and well, too bad. I mean, I know that listen, I don't think there's anything wrong with REST. I know that there's the issue is that there's a lot of use cases out there for REST API, especially in e-commerce, where you sometimes you might have other API services, etc., that are more legacy that don't support fetching from a GraphQL API or whatever. And I know that there's a use case for that. I think they're really more targeting the more future-proof, forward-thinking retailers that just want to have the latest and greatest of everything, and so that's why it's 100% GraphQL and there's no REST API. Otherwise, it would kind of be kind of be a multi-headed monster. That's how I would describe it. So if we can move to the next slide, and
I think there is no point as well to be to have both, right? If you have GraphQL, I would not see the point of having GraphQL and REST. Choose one, I guess. But,
especially if you, if you're used to REST, the transition to GraphQL can be a little bit. It can be a little bit hard at first, but really it's not that complicated. And both of them are HTTP at the end of the day. You hit an HTTP endpoint. It's just a matter of passing the data in a specific format, etc. Obviously, it's better if you use a GraphQL client that will form the queries for you, etc. But you don't necessarily have to. Not that I would recommend it, but it's both are HTTP calls to an endpoint at the end of the day. So I would say it's not like it's built on WebSockets or something completely different like this. It's still the same protocol. So
cool. So I see more and more people are joining. So just to remind everybody what we are going to do today, as you are joining, maybe you didn't catch the beginning. So we are going to deploy Open Commerce on AWS using MongoDB Atlas. So we're going to build a big production system. Loan is going through right now a few slides. We have like 5, so won't be long for sure. We're just discussing a bit about what's Open Commerce and how we're going to build it, and we're going to start live coding and hacking through AWS and MongoDB Atlas very, very shortly. And you will probably most likely see us failing quite hard, because that's actually
that's the whole point of it.
Yeah, that's the whole point of doing this live, so we can be ridiculous in front of thousands of people. So yeah, that's the cool part. Back to you, Loan.
Yeah, next slide. I think I've gone over all of that. Yep. All right. So what you can do with an API first e-commerce platform is this is the whole point of it, right? What you're seeing here is instead of just having one big monolith that also serves the front end and does all of the backend logic, etc., all in one project, where you're kind of restricted, and there might be an API, but it's kind of an afterthought, and it was built on top of everything, etc. It's not great. Well, instead of that, when you use an API first system like Open Commerce, you can have a web storefront, you can have a web admin UI. On top of that, you can have your mobile app storefront. If you have a native mobile app, for example, connects to the same API, fetches the data from there, places orders, adds to cart, etc., just like the web storefront does. All of these UIs can be completely custom. So you can build your native app, with React Native if you want. You can build it with with native languages if you want as well, using Swift and Kotlin, if that's what you're into. You can really take all the routes that you want, and you can also, on top of these pretty standard use cases, you can use you can build purpose-built microservices. So if you wanna have a microservice that just sends all of your orders to a third-party system, for example. If you have an ERP to connect to, or even way simpler, you just need to call this API route every time a new order is placed. You can have a microservice to do that if that makes sense in your infrastructure. I'm not saying such a simple use case warrants for a full-blown microservice. Usually it doesn't, but it's a possibility that you have, and it's much more simple with an architecture like this. And you can also build cool stuff like an in-store kiosk software or whatever. Really, the sky is the limit in terms of what you can build. Once again, Open Commerce is nothing more than a GraphQL e-commerce API that you can tap into, and it's open source, and it runs on Node.js, and as you can see here, it also uses MongoDB. So I don't know about you, but for me, it's pretty much the perfect setup in terms of what our clients do, etc. It just makes the most sense usually to have all of this flexibility. It's not going to be for everyone, obviously. It takes a lot more work than to build a Shopify website, for example. But usually, it's not the same retailers that use these platforms. So we have Ron in the chat. Hey, Ron, by the way, a contributor from the Open Commerce community, open source contributor, responsible for a lot of the greatness behind the project, by the way. I want to give a shout out to Ron right here. He's been very involved in the community for a long time, and actually wrote the key piece of software that, not really software, but the key piece that we're going to be using later, you'll see, is that is thanks to Ron. So thank you very much. He's saying that an image conversion microservice is a good example. Yeah, that's true, because it's very I think it tends to be very CPU intensive, etc. When you have image conversion, if you want to like resize your images, crop your images, whatever, programmatically. That's a great example. But once again, the sky's the limit. Whatever you can think of, even if it's very unconventional, you can do it as long as you can write it in any language and just consume the GraphQL API. So really super simple in terms of the setup. Obviously, the implementation is harder than Shopify and whatnot, but once again, not the same use cases. So I think that's all. We can get going. I think the next slide is, there we go. Let's hack. So Maxime, I'll hand it over to you and can take it from there.
Whew. All right. So let the mess begin. So let me get rid of the banner. Where is the banner? All right, cool. Let's get rid of the slide deck, get rid of this. So where do we start? We start in, I guess, I think we can start in AWS.
Yep.
And
we're going to explain to people that we already have a cluster. So
yeah,
we're just starting the live. We're already lying to you. It's not fully live. So we have a cluster because it takes forever to create a new cluster. So we just have an empty cluster sitting here, but we're going to explain to you how to create it.
Yeah, it takes about 21 minutes. We actually had to do this yesterday. So yeah, so to build this, basically you have to follow the doc. So from what we've done, so you go to AWS, of course, you need your own account, etc., and then you can go to AWS EKS, and you can click on clusters here. And so we created a cluster that we called Open Commerce Cluster. So I can share with you the command lines that we used. Actually, I can show them in here. So it's not a good idea to go in here and click create cluster. From our experience, it just doesn't work that well because it's going to forget a few things that are actually required to make this work. Like, for example, we didn't have like machines. We didn't have had nodes in the cluster at the start. So like the things like the core DNS, the AWS node, and the kube proxy that is required and deployed by default that we need, for the networking and for all the internal stuff in Kubernetes, like just didn't work because we didn't have a machine. So yeah, so from our experience, at least, it's way easier to do this with the AWS CLI. So let me just have a look in my notes because, of course, we have a bunch of notes.
More specifically, EKS CTL. So you have two ways of deploying a cluster. You can use EKS CTL, which is kind of AWS's more simplified EKS specific command line. So if you already know Kubernetes, first of all, you're probably going to laugh at us during this live stream. So please stay tuned. But if you already know Kubernetes, you probably already familiar with kubectl. EKS CTL is kind of AWS's own kind of version of that, specific for EKS, and it simplifies things a lot rather than just using the normal AWS CLI. You can create an EKS cluster with the AWS CLI using AWS EKS blah 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 create cluster. You can do that, but it takes a lot more arguments. It's a lot more verbose. It's a lot more work than just using EKS CTL, which is more what's recommended for beginners.
Yes, so we've been through the doc and we installed those tools. So we had to install the AWS CLI. We had to configure it, so it knows like our IDs and secrets and everything, so we can actually run commands and execute them on the AWS services. Same for EKS, which was pretty straightforward. I think it was pretty easy to configure, from what I remember at least. And then you can execute these two command lines. I hope it's big enough. It looks like it, at least on my side. So with the first command line, you just create a key pair, which is basically the key pair, so like the security RSA key that you're going to create, and that is used in here for those two machines to be created, and so you have access afterwards if you like.
So just one thing. This is only needed if you want to enable SSH access to your machines within your cluster. If you don't want SSH, you don't need to create the key pair.
All right. And then you can execute this command line. So the EKS create cluster, which really does everything for us, right? And it's better than doing it with this create cluster command that's somewhere in here in the UI. It really automates everything. I guess we just use like the default options, like, just come with this command. But I guess if we wanted to, we could also say, I don't want 2 nodes. I want actually like 20 nodes maybe. And I want, like some different instances. For example, like it came with M5 large as default. Maybe we could have, say something different. So we just went with the default. It's working for us. We are just doing something, nice and simple for this tutorial, so it just works out of the box for us. But maybe we could have done something a bit different, with this command line. The log of this, I guess I can share the logs. I hope there are no secrets too much in there, but the logs looks like this. I'm going to make this big. So we can't execute this. Well, we could execute this, but it takes about like 21 minutes to go through the whole thing. So we are just, trying to save a bit of time here. But the logs looks like this. So if everything goes right, you just see that it's deploying something, and it's like provisioning the whole cluster. So yeah, so we see control cluster plane, etc. So yeah, so it just starts to configure things. It's also creating in the background some security groups and like all the AWS background, underground thing that you don't especially need. Like, for example, it's also setting up the CloudWatch for the logging system, etc., etc. So then it does
also sets up a VPC specifically for the cluster, which is separate.
It's probably listed somewhere. I can't see it because I'm absolutely blind when I'm doing a live stream, which is not very cool. But
as you can see in the timestamps, it's taking a lot of time. This is something really. When you start this, you want to go and go outside, walk your dog, get yourself a coffee. You have time to do a lot of stuff during this operation.
Buy a car, make kids, grow them, like bring them to school. Like you have really a lot of time. So yeah, it takes about like 20 minutes. So we started like at 9:40 and it ended up at 10:01. So yeah. So yeah, it creates like all that stuff for us. As you can see, we have a node group with 2 nodes. We have what else? Yeah, we have node group. We have kube system. So you will see in the Kubernetes system, we have actually like 2 namespace, one for the system, which is kube system, and we're going to use another one for our content. So yeah. All right, so it looks like this, right? So we won't spend too much time on this. It's not the super interesting, but it looks like this. All right, so next step, what should we do after that? So, hi everybody in the chat. I see some people saying hi. So, hi everybody.
And
thanks for joining us, being live.
By the way, hi Akarshit, who works at Mailchimp and works on the Open Commerce project. Has been for a long time actually. He was here even before Open Commerce. So, great to have you here.
Thanks for joining, and really happy to see so many people on the live stream. That's very cool. Of course, it's going to be also available after that on YouTube. We're going to share the stream on YouTube. So if you want to watch it again or do pause because you need to copy paste commands, whatever, we're gonna try to like do a blog post, I guess, about this, or some kind of repository, I guess, so we can share all the commands line. It's not ready today, so we can share it, but we're gonna polish this in the next few days, I guess, and publish something like this. All right. So what's the next step, do you think, Loan? Where should we go next?
So the very first step when you have your cluster is, so as you said, that command, that create cluster command, will set you up with nodes, etc. So you have everything you need to start deploying stuff on your cluster right away. But the first thing we want to deploy on the cluster is not Open Commerce itself. All right. So that's a bit counterintuitive. The first thing that you want to deploy on your cluster is something called AWS Load Balancer Manager. So this is something that will run inside. It's a piece of software that will run inside of your cluster, and it will basically watch for any ingress. Ingress is what we use with Kubernetes to do reverse proxy in front of services. It will watch for any ingress being deployed that is deployed with specific flags to tell this piece of software, AWS Load Balancer Manager, that we need a load balancer to be created automatically for this ingress resource. So it is very important to deploy it before you deploy Open Commerce, because otherwise what's going to happen is you're going to have Open Commerce running, you're going to see logs and everything will be great, but you're not going to be able to access your services. So that's going to be a little bit of an issue. So obviously we want to start doing that first. I see you have this IAM policy right here. Yeah. So we need. Go ahead and explain the service account. Sorry.
Okay, I go for it. Sorry. So yeah. So to do this, we actually, we've tried, this before the live stream. So we already did a few things. And we have a Cisse in YouTube that says, hello, what did I miss? So what did you miss? We are building, we are using MongoDB Atlas and Open Commerce. We are building a production environment. So we are using Kubernetes, we are using AWS services, and we just started actually. So now we have a Kubernetes system that's up and running. We just run a couple of commands to do that. And now we're gonna proceed with installing the AWS Load Balancer controller that we need, because when we deploy Open Commerce on Kubernetes, we need some automatic load balancing system to be on front. So we have, in the end, access to the nodes we're going to deploy in Kubernetes. And this is completely automated with this in AWS. So we're just going to use it, right? Because it makes our life like so much simpler. So to do this, we actually already did some part of the installation. So as you can see, we don't have any AWS Load Balancer controller running in the system. We removed it. So we're going to show you how to do this. So the first thing you need is you need to create a YAM user, or is it a service, or I don't know the name exactly, but it's not a big deal.
It's a service user.
Service user, right?
A user that's going to just have roles to deploy load balancers. That's it.
Yeah. And so we need to create that. And to create that, we need also a YAM policy that basically allow you to create those kind of services within a Kubernetes cluster and within the system. So the first thing, AWS, it's from the AWS doc, right? So we are not making anything up. So if you want to reference to this, it's just directly in the doc from AWS. So basically you just download the policy. So we already did this, so I'm not going to re-execute this because we already have the policy that just exists. It's just not going to disappear from one deployment to another. So it's just a one shot. I'm using my other screen. I have my microphone in the middle now, so it's a bit hard for me. Once you have downloaded the policy, you just create it like this, and you give it a name, like AWS Load Balancer Controller YAM policy. And when you have that, you get an output. And in the output of this, you get, what do you get? Oh yeah, you get, so the policy looks like this. I hope I'm not sharing too many secrets, but that's a game, So the output you get looks like this. You have a policy and you get an RN like this. And once it's done, you can create the YAM service account. Let me just grab that.
all of that will be deleted after the stream anyway, so don't try anything.
Oh yeah, it definitely will.
I don't think there's any secrets in there anyways, but hey, if there are, well, all of that is going to the trash afterwards. So
23 seconds exactly after the end of the stream, I'm gonna blow everything up. So like, even if you try,
and you will
it's
see
not there anymore.
You'll see that blowing the whole thing up is just one comment. So it's very, very simple to do that.
Oh yeah, it's way easier to break it down than breaking it up to speed. So yeah. Are the content of this text available to us anywhere? No, not yet, but I will share it somewhere. I guess it's going to be on the MongoDB developer GitHub account. I will create a repository after that and drop down my notes. We didn't finalize everything, like all the notes. It's not all square and, all, everything is sorted and yeah, square. But I'm going to do that, yeah, after the stream. No worries. Cool. All right. So yeah, once you have done this, you can execute this command. Once you have created the policy, you did this command, create YAM service account. Yes. So you use EKS and you create the YAM service account. That's using this. So you give it a name. You provide the RN, the one that we just got, from the previous command here. You say overwrite anything that already exists, etc. So this as well, we don't need to do it again, right? We've done that already. So we don't need to do that again.
Just as long as you have that, as long as you have that policy set up and that user set up, you can just reuse it for as many clusters as you want. So shouldn't be a problem. As far as I understood. One disclaimer I want to make is that we are not experts at Kubernetes. We don't have any rights to claim that. And as much as we're trying to show you a production deployment, anything that pertains to security, please do your own research and please consult a professional. Do not take our advice for security, otherwise everything's going to blow up. This is not something that I would advise you. If you're doing this at your job and this is for production, great. Follow to get a basic idea of how it works, follow this live stream. But for real stuff, especially for security concerns, please speak with someone who knows what they're doing and can look at your setup and can verify that you're doing the right things. So we will not be held liable for anything that will go wrong following our instructions, because we are beginners as well. So just to clarify this.
Don't do this at home. And if you do, please, consult any adult, consult anyone that,
please do. And we do not qualify as adults, so please don't come to us for that.
All right. So the next step is so next step you need to install. So you use Helm. So we also installed Helm. It's just one small binary to install. Very, very useful. And you just install this. You say repo add EKS, and you just add these AWS EKS charts. You do update just in case, and then you can drop this command line, and that we're going to execute, which is this one.
So just for anyone who's wondering what is Helm, it's a very handy tool that works in conjunction with Kubernetes and allows you to deploy things on Kubernetes so much simpler than if you were to just describe all of your services manually. So if you use Helm, you can just have your entire infrastructure described in what they call charts, and charts are just YAML files basically. And you can have your whole infrastructure just described, all of the services described as YAML. With all of your, you can provision it with environment variables that you can set depending on the deployment, etc. It's really, really handy. That's why we're using Helm for, to install the AWS load balancer controller, which we're installing prior to Open Commerce. But you'll see that we're going to use Helm as well to install Open Commerce itself. So just a little quick explanation on why we use Helm, just because it makes our life so much easier, and otherwise we would be here until tomorrow.
Yep, exactly. So this command we need to execute now. So the stuff we have at the top, it's just create a policy, create a YAM service account, and then we just use this service account, to control all our AWS load balancer controllers, from now on, right? So you just do all this stuff once, in your life on your AWS account, and then it's done, right? You don't need to do that ever again. So that's what we've done. And then you can execute this command. So install the AWS load balancer controller. So also something I didn't mention, but the first command we ran, to create the cluster, the very first cluster on, we've done earlier, it sets up automatically our environment in my PC. So I have the .cube, like config folder in my Linux now. And like everything is automatically connected to my cluster in AWS, right? So like when I execute Helm or EKS, whatever, it just goes directly to the cluster. So I don't need to take care about, all the security layer anymore. It's already pre-connected, preloaded. All good. All right. I'm reading the chat as we speak. All good. So in here, Helm install, I install this. The only thing that I have to say about this command line, which is like pretty straightforward, again, it comes straight from the doc from AWS. Nothing too fancy about it. You might just notice this image repository weird thing here. So this is provided as well by AWS. We are at the moment playing in the Paris AWS data center because we are both French, as you may have noticed. We have both a very cute French accent. So this is a stream, sponsored by the French. We are strong and we are here. So these two, so this number here and of course this, it's provided by the doc, and it's different from one data center from another. So you need to adapt, this if you're deploying from one place to another. But basically that's it. If you just take the command and change this, it should work out of the box. So let's execute this on our cluster.
Finally running commands. There we go.
Finally, the first one. So hopefully it should just run out of the box.
So once again, for the people who just joined us, we're not deploying Open Commerce just yet. We're deploying the AWS Load Balancer Manager, which is something that will allow us to have load balancers created automatically once we deploy Open Commerce, make our life so much easier. So that's the first step that you need to take once you have your cluster created and all of that in your policies all set up.
So now that I have this, I don't know why I'm struggling so hard with this, but all right. What am I doing? Anyway, so here, if I refresh, let me just put this full screen. So here, if I refresh, I should have force a new AWS load balancer controller, right? So it's in here. Again, it's a part of the kube system. It's not directly built by default in the Kubernetes system when you just build up, your new Kubernetes cluster, but we just added it now, and so we should be good to go. So basically, what this does, as a reminder, each time we deploy something that has an ingress within the cluster, it's going to be automatically, it's going to create automatically for us some load balancers in EC2, so we can join and reach, those ingress in Kubernetes. I hope I'm not messing too much around with the vocabulary of Kubernetes. We are just, noobs, as Loan said earlier. So yeah, we are doing our best with the vocabulary here. But looks like, it's here, it's up and running, and looks like it's all fine. It's green. We asked for 2. We have 2 runnings. And as a reminder, we have 2 nodes, so it looks like they are both sharing, one node. So we have some redundancy, and we should be, already fail-proof. If one of them happens to fail, it should be up and running still. Cool. What's the next step, Loan? What should we do now?
So now that we have the load balancer manager that's installed, that once again is going to spawn, load balancers for every ingress on which we request explicitly load balancers to be created. Now we will dive into deploying Open Commerce, but we're not going to go and deploy Open Commerce just right now. What we're going to have to do a little bit of work before that. So first of all, let me introduce you to the tool that we're using to deploy Open Commerce. As I said, we're using Helm for this whole tutorial, and we're going to be using the Helm charts provided by Demand Cluster. which is a company based in the Netherlands, and they're working a lot on open commerce, and they're doing a lot for the open source community of open commerce as well. And Ron, who's in the chat as well and watching this live stream, I believe, has written amazing Helm charts that just basically do all the work for you. So that's why we love them. As you might have noticed, anything that makes us gain time and makes things simpler, we love, because we're very lazy. And that was just the pinnacle of laziness, just using these charts. Everything is made for you. So Ron, thank you for that. Basically a godsend from the community here that we're going to be using right here. So instead of having to just manually describe each service, etc., you can just use that, and you can see that we can customize as well the deployment. We can tell it what services we want, what services we don't want, what environment variable to pass, etc. Basically, you tell it all of everything that you need to tell it, and then it will deploy everything for you on the cluster. So that is, as I was saying, you need to tell it exactly what you need, right? Otherwise, it's just going to deploy defaults. So if you don't tell it anything, it will deploy, for example, a MongoDB replica set, which we don't want because we already have MongoDB Atlas, where we're going to be creating a database there, which I think is the next step. So you have this values.yaml file here, where you can just customize pretty much every single aspect of the deployment. You will set MongoDB to false right here. And at the top, you will provide your own MongoDB URL. Ron, if we say anything wrong about your Helm charts, please let us know in the chat, because you're the one who wrote them. So what a pleasure to have you on the stream right now. And if we say anything wrong, you can correct us live. So you will need to provide your own MongoDB URL here, which we're gonna get from Atlas. And then the rest we'll just go through it in due time. For now, I think we should create the cluster on Atlas. And actually, I'll be careful. And actually, the first thing to do before creating the cluster will be initiating a VPC peering connection between Atlas and AWS. But Maxime, I'll let you explain how that works, because that's not my area of expertise.
Oh, I can do that very easily. Look at that. I have a space right here that's actually very conveniently empty, so I can draw in here. So look at that. So basically how it works, it's very simple. So that's AWS, that's your network, and we're going to deploy all our cluster and everything, open commerce, everything in here. But we're going to use MongoDB Atlas, which is here. And MongoDB Atlas creates for us some nodes, so 3 nodes, like a replica set, in also in AWS, and both, like, we are in Paris in here with our Kubernetes cluster, but Atlas also creates, it's also using AWS, but it's not the same account, right? So it's going to create a different VPC. So that's the VPC from AWS, that's the VPC from MongoDB Atlas, which is basically, sending the orders, from MongoDB Atlas to AWS to create the cluster, do all the setup, etc., etc. But the question is, how do we make these two communicate together, right? So that's basically what MongoDB, the Atlas peering service is about, right? So basically, you can create some sort of secure tunnel, between these two VPCs in AWS, so they can communicate together. So basically, if this represents the data center of AWS in Paris, everything stays within the data center of AWS in Paris, right? You don't need to expose your MongoDB Atlas connection to the internet, to the public internet, and then go back to the VPC to reach your Kubernetes system anymore, right? So you don't need to do that. You can go directly in the VPC network and share your connection directly in the network. I hope my bike, is beautiful, right? It's a beautiful bike.
It is a bike. Now that you,
it is a bike. No,
I'm just realizing that. Yeah, it is a bike.
It's a bit crippled, but that's a good way, I think, to explain AWS VPC peering. So, what it is, to sum up, it's a bike, right? It's a beautiful bike. Why am I stuck? All right, I'm not stuck anymore. Cool. So that's basically the way it works. So we want, of course, this because that's an extra layer of security. And in the end, if you use the VPC pairing, it means that your MongoDB Atlas cluster can be like completely not exposed to the internet, right? So there is no surface of attack or anything, because like you're not even exposing it to the world. That's hard to say, to the web, right? So so it's completely safe, and like, yeah, so no problem, right? No problems if you don't share anything. There is no problem. That's basically what I'm trying to say. So we will need to set up this. We will need, of course, to set up a MongoDB Atlas cluster. I think we can start with this. We're also going to use HTTPS, so we're going to use OpenSSL and RSA. And like,
we're going to be using ACM to generate the SSL certificates.
Yep.
So ACM is a product from AWS that just makes your life so much easier when it comes to generating certificates. And guess what? It's free, if I recall correctly. Don't make me liable for that, because it might not be free nowadays. But last time I checked, it was. And you can just create certificates in 2 clicks in AWS. So we're going to be using that for SSL.
So we're going to do that as well. We're going to show you how to do that. Hi, Dropdeep. Thanks for being around. Thanks for being on the stream. Cool. So let's have a look. So we go into MongoDB Atlas now, and we create the VPC. What do you think? Next step?
Yep.
All right.
Good way of starting.
Cool. So in MongoDB Atlas, so you can reach this by just going to cloud.mongodb.com. I hope it's big enough. I guess I can zoom a little bit like this. If it's not, please remind me, but looks good. So we have an organization in MongoDB. So I'm in the developer relations team. So we have an organization that's called Developer Relations. And within this organization, we have a few projects. Actually, we have a bunch, and I created a new one called Open Commerce, right? So it's completely empty. There is nothing in here, and it's a brand new project, right? So it's completely blank. So first thing I want to do in here is show you a bit around. So we have a few things here. We have the databases. As you can see, I have none actually. So it says create database. I don't have anything right now. We could also use triggers, which is actually part of MongoDB Realm here at the top. MongoDB Realm, it's part of my team actually. I work in the MongoDB DevRel Realm team within MongoDB. And this, what it is, it's basically Realm is a backend serverless system, which is of course as a service. And you can use it on top of MongoDB Atlas to build like anything to expose your MongoDB cluster. So for example, you can build very easily a GraphQL API or a REST API. That's actually my talk at MongoDB.local London that I'm doing in a couple of weeks, I think. I think it's on the 9th of November. Let me just double check that. MongoDB local London. So it's right here. And it's, on Tuesday, November 9th. So it's in a couple of weeks now. And I will be presenting this talk about how to create GraphQL and REST APIs there. So if you want to register, please, of course, join us. It's super cool, and you have very deep, very cool presentations, like a deep dive like this, to explain and share more, details about MongoDB and about like all the ways you can interact with MongoDB and Atlas and the whole platform. And you can benefit from my special code, because I have a small code you can use. And it's very easy. It's Beugnet 75. So you can use it to register, and you have a discount of 75%. So if you want to join, please just do so, and I will be happy as well to meet you there and share my presentation. So please join. Cool. What else? So MongoDB Realm, so GraphQL, REST API, HTTP services connections. You can also connect with AWS and S3 buckets, for example. You have authentication services with Google, Facebook, Apple, whatever. You have like really a lot of services available in Realm. And you have also a new feature which is called Realm Sync, which allow you to also sync the data across multiple devices if you are doing some mobile devices, some mobile applications, for example. And we have also the Realm SDKs, for Android, iOS, and web as well, Kotlin, etc., etc. Like we are covering a lot of different products like this. So you can also sync your data across different devices using Realm Sync, and of course, everything lands in the end in your central MongoDB Atlas cluster at the end. So it's very, very easy to do that. I have also another presentation about this, which I already presented, and maybe you can find the replay online. It's Web Expo in Prague. So yeah, if you want to check that, it's a cool presentation as well. And we have MongoDB charts as well. So in here, you can produce a dashboard using MongoDB chart, and you can like build a few charts. If you want to see an example of charts, you can go to my blog post, which is in here in developer in the developer dev hub. So I'm going to show you that as well. So this is the technical blog, of MongoDB, where you have a bunch of things. So that's one of my blog posts actually. So how to embed MongoDB charts using React. But the other one I had in mind was about the COVID. So if you type like coronavirus in here, you have one of my blog posts where I build like a tracker of the COVID and all the stats. And you can build some stats like this and a dashboard that looks like this. So it's going to load at the top. And you're going to see like a few charts like this. You can have like a white or dark theme. And you can build these kind of cool dashboards if it wants to load. Why is it not loading? Oh, it is. Just a lot of information to process. So this is updated automatically every hours. And there's a whole lot of data now in the COVID charts. So yeah. So it looks like this, right? And you can build those kind of charts in MongoDB charts and embed those into website, blog posts, wherever. It's super simple to embed, even with React. I have a blog post about this. So yeah, just a small example of what you can do with the MongoDB platform today. And yeah, you can also remember this. So mongodb.com/developer. And in here, you have like all our technical content with some tutorials like this. Like what we're doing right now, it's probably going to end up being a technical blog post, at some point, I guess. Back to MongoDB. So you have also the data lake, and you have all the security layers, to secure your database. So we're going to use this to provide access to our Kubernetes cluster and only our Kubernetes cluster. So the first thing we're going to build in here is VPC Pairing. So for the VPC Pairing, you go to Network Access in here. You click on Pairing, and you add a new pairing connection. So to do this, we are using AWS today. So we're going to just select this provider, and we have to provide a few informations. One thing to note here at the top, it's only for M10 and above only, because in MongoDB Atlas, you will see that we have several tiers. And the first one at the top, they are shared tiers, actually. So it means you are sharing the cluster with someone else, or with some other people, right? So it's not possible to use the VPC pairing with this, because it means that you would be sharing your VPC, your private VPC, with potentially some of the people that already would have access to that cluster. So for security reasons, you can't do that, right? It's common sense. So let's provide all these informations and create the VPC in AWS. So what we need here is our account ID in AWS. So to get this, I just go here at the top. I can retrieve my, oops, if I can copy paste, I can retrieve this. So that one was easy. VPC ID, I can get this in the VPCs. So as we said earlier, if I go to VPC in here, so when we created the Kubernetes cluster in AWS, it automatically created a few things for us, including a VPC. So you can see this actually right here. I have a couple of VPCs. I don't even know, like this one is something else, it's an old one. And
that's your default. Here, that's your default VPC. When you create an AWS account, you always have a default VPC. So
that's it. All right, so that's a default VPC then. And so this one is the fresh one we did. As you can see, Open Cluster Commerce. That's the one that's linked to our cluster in AWS. So I need to retrieve the VPC ID, which is just right here. So I can copy paste this and this. Next step, the VPC CIDR. So this I get from the same. I'm expired. Let me do that again. Refresh this. Maybe I can refresh this. No, I can't. All right, let's look back again. Come back here. VPC. All right, so in here I need the VPC CIDR, which is just right here. So I just need to copy paste this and here, right? So there is this button here that is going to add automatically this CIDR into my IP whitelist. So it means that my Atlas cluster will be listening on that CIDR to be able to, be reached. Else, it's not answering on anything, right? So it's secure by default, and you don't trust anything before you actually say so. So yeah, everything needs to be explicitly set up, to be reached. So we are in Paris. So I'm just going to select this same region. And we are also in Paris in my cluster in AWS, in MongoDB Atlas. So I will make sure to create my cluster as well in Paris. So we are in the same region. And we can just keep this ticked as well here at the bottom. So same application VPC region. And at the bottom here, we have the VPC CIDR. So we can take anything. And do we change this, Loan? Do we want to change this?
So if we keep that, it's going to be conflicting with the VPC CIDR. So this is the CIDR that the Atlas VPC is going to be using. So just for safety and to keep things separate and to avoid conflicts, we're going to be using something like 10.99.99.0/24 is going to be fine. Yeah, that's what we used on our tests. If you are someone who knows, networking, then you will probably have stronger opinions than us in terms of, what should be used there. It's really up to, your preference, your personal preference, and your, conventions within your project as well. So, we're just going to be using that for the demo, but don't take our word for it.
Yep. All right. So as you can see, MongoDB Atlas is doing the provisioning for me. So as you can see, it's pending now because we need to validate this in our AWS account. It's not just us saying that we want to connect. We actually need to validate the connection in AWS side. So as you can see here, there is a little helper. How do I approve this connection? So I can just click here, and it tells me how to do that. So we need to go to AWS, select the peering connection, and we're going to do that right now. So going back in here. In here, we have peering connections. As you can see, we have deleted this one, which was the old one we were using for the working. So that's a new one that needs to be validated. So I'm just going to click here. And I think I need to get in. Yes. And I need to say action, accept. Just summarize, all the things I have set up so far. And I just say accept request. And that's it. We are up and running. There is one more thing that we need to do. If I click next in here, as you can see, I need to also set up the root table because I need to be able to reach. So I need to authorize MongoDB. We need connection in both, both directions, right? So we also need to set up the root so our VPC can reach MongoDB and, Loan, help. I can't explain this.
Yeah, so
it's both direction, right? So we need to authorize the root, right? Basically.
So if we don't add this to our root table, the problem is that our pods inside of our cluster will have no idea where to reach, these 10.99.99.0 IPs. It will have no idea, where to go to find them. So you won't be able to reach your MongoDB cluster within Atlas if you don't add this to your root table. So that's what we're going to do right now. You'll see it's very simple. So we're just going to go to root table. Do you have your peering connection ID that you have? Oh no, but it's going to be in the dropdown, so it's fine. All right, so We're going to go to the public. So you'll see you have a bunch of root tables that were created with your VPC for your Kubernetes cluster. We're going to go to the public one, which is the only one that says public. Just go in there, roots. And we will add a line here in the root table for 10.99.99.0/24. And we will add the VPC peering connections right here. And we're going to have that's single option that is available right now. And just save. That's enough to tell our everything within our VPC how to reach this IP block that belongs to the Atlas VPC.
Yeah, I'm double checking that's actually the right one, but looks fine, right? Looks
it
like
should be the only one that it allows you to. Yeah.
This is the right one. This is this one. So yeah, the right side of the block, etc., etc. So everything is in place.
Always double check. Better safe than sorry.
Exactly. All right. So now that this is in place, we should be able to. So like I explained, earlier with my nice schema and my nice bike, we have now connected our VPC from MongoDB Atlas with the VPC of our Kubernetes cluster, right? So both can now safely talk, to each other and stay within the private, network of our AWS data center, basically. The link to MongoDB local London, sure, I can share this. London, MongoDB, what is it? MongoDB local London, local London. Let me find that here. Sharing this to everyone in the chat, and you can use the code to get 75% off, like this. Cool. All right.
So now, what's our next step? Now, are we creating a cluster?
So that's done, and yeah, we should create a cluster. So let's get back into database. And
cluster or user first?
That doesn't matter.
You don't have a preference now?
No, it works both ways. No problem with this. The only thing that I want to make sure everybody saw, we created the peering, right? The Atlas CIDR block here was also added to the IP whitelist here, right? We haven't done anything, but it was ticked by default. So we have added now this IP address here. So if you come from this IP address, then you will be able to connect to our cluster. Basically, that's what it means. And if you have the right user and password as well, that does not exist for the moment. So we're going to do that right now. So now let's create a new cluster in MongoDB Atlas. So, and of course,
Maxime, while you're doing that, I'm just going to go grab some water. I'll be back in 2 minutes.
Oh yeah, no worries. And of course, like this cluster will use by default the VPC connection that we just set up. So we don't need to worry about anything here. So we're going to click on build a new database. Here I have a few options. We have a new serverless option that's in preview right now. And we have also some free tier. So for this demonstration right now, it would not work with the VPC pairing. You could do exactly the same thing, though, if you don't use the VPC pairing and use the public connection through the internet, right? Because it's shared, you can't, plug a private VPC to it. But that's it. So for the purpose of this demo, we're going to use a dedicated cluster here. I'm going to click create. And so I'm going to click on to dedicated here at the top. And here, I think it's a bit big. I'm going to unzoom a bit. So we have a few options. So first, we have to select the cluster tier. So I'm going to select the small one, M10, which is the smallest one we have. It's 2 gig of RAM and 10 gig of storage. It's just 9 cents per hour. And this is for 3 data-bearing clusters, right? 3 data-bearing servers, because by default, MongoDB works, with a replica set of 3 machines, 1 primary and 2 secondaries. So we want, to deploy something that's actually production ready. So that's what you get by default for 9 cents an hour. Here we have auto scaling enabled. So it can scale automatically from an M10 to an M20 by default. If I don't want that, no worries. You can just untick that box and it just works like this. You have also the storage scaling automatically. So if you ever reach or come close to those 10 gigabytes, it's just going to increase for you the storage automatically up to 128 gigabytes. But with 2 gig of RAM, that's definitely not a good idea. So you might want to use the feature of, updating the cluster before that and upgrade to like an M20 or an M30 like seamlessly, right? Because MongoDB Atlas allows you to just upgrade the cluster without downtime, which is very, very cool. So I'm just going to use a small one here, M10. As you can see, we have also like the M700, which is way bigger, a lot of RAM, a lot more storage, and a lot more CPUs, right? So of course, a lot more expensive, but you get what you pay for, basically. In here, I can select my cloud provider. So today we're working with AWS, but I could also do the whole thing. I could just use GCP or Azure as well. So like I said, I'm going to stick to AWS in Paris. So I stay within the same VPC and the same data center. So I have low latency and a smooth connection. In here, I can select the version of MongoDB. The latest version of MongoDB is MongoDB 5.0. But for this demo, I will just stick with 4.4 because for now, Open Commerce is still compatible only with MongoDB 4.4. So I'm just going to stick with MongoDB 4.4. We have also a backup option. So if you are doing a real production environment and ready, system, I would definitely turn on the backup. So you have a backup every, 6 hours. And you have also the way to configure the continuous cloud backups. So you have a recovery point objective of 1 minute. You can actually achieve this with this option, right? So you can retrieve your data up to a point in time in the past and recreate your cluster entirely from scratch, with just a few clicks with this option. So it's pretty cool. You can also shard. So start it from the N30. So if I go for a bigger cluster like this one, I could also choose to shard my environment and say, all right, I don't want one replica set in MongoDB. I want 5 of them. So that's 15 machines. And I can also choose to actually deploy them worldwide. I don't know where the option is gone now. Apparently it's moved to some other places. Where is it? Cloud and region. Where is this? Right, they hit the option somewhere. Can't find it. Interesting. All right. Where is the global? Let me cancel that for a second. I will do that later. Advanced configuration options. Yes, here it is. Global cluster configuration. So if I wanted to deploy Open Commerce, I want to start an Amazon shop or something huge, right? I could just turn this on as well, say AWS, and I could choose some excellent global performances, and it would deploy for me several MongoDB. I'm losing my words. Shards. So it would deploy multiple shards, in different regions of the world. So I would have a good latency, in all the different regions of the world and cover as much as possible, right? So, and this is completely tunable, right? This is just a template for you that's automatically set up, but you can, play with the zone. You can add more, you can remove some, and it's completely dynamic, right? So, for example, if I remove North America East, for example, I just trash this. As you can see now, it's the North America West cluster in Oregon that's taking over the whole US and North America area, for example. So that's a bit too complex for what we're trying to do here. So I'm just gonna go back to my initial thing and just produce something very simple. So dedicated M10 with no scaling. I want in Paris, in AWS Paris. I want 4.4 without the cloud backup because I like to live a dangerous life. And then I can just name this Open Commerce. And that's it. I just click on Create Cluster. And now in 7 to 10 minutes, I will have my machines provisioned for me in AWS within my VPC and connected already to my VPC Pairing connection. So everything will be set up in just a few minutes while we are working on the AWS side. So yeah, that's it. I hope I didn't forget anything, Loan. I think I've been around.
No, that seems pretty complete to me.
I forgot the user, so now we can create a user. So here I just click on database user, and I'm just going to create my cluster user, right, for this cluster. So I can just name it all right. So this is going to be my God user. That's fine. Let's name it God like this, and I'm going to choose a password. Super safe, of course, so nobody can guess, my password, right? It's definitely not super safe. That's it. So you have a few different options as well to secure your user. Just put this guy as an admin Atlas, just in case. I think it's mandatory, right? Because we are actually reading the uplog, right, in Open Commerce. So I think we need that.
That's right. It's the admin UI, which is on Meteor, and Meteor does uplog tailing, which is something that we used to do back when we didn't have change streams. But nowadays, it's not really something that you should be doing. So, don't do that at home, obviously.
Yeah. So in the meantime, it just works like that. So it's totally fine. And I'm not afraid, to share this user with you because, I'm going to blow up everything at the end anyway. And also because, even if I give you like the password and the user and the password, I can create this user. But because of the network access settings, if you don't come from this IP address, which is impossible because it's local, because of the VPC peering we've been doing, like there is no way to connect to this cluster. Like even right now, I can't connect to this cluster without being inside the Kubernetes cluster, basically. I hope it's clear for everybody. So that's it. We are, I think, ready for the MongoDB side. So now we can just go back to the VPC, so to the EKS cluster and set up the rest that we need. So we can go to the values file, I guess, right now.
Yep. So we're going to need to modify our values.yaml file locally that we're going to be passing along with our Helm install command. Once again, to install the demand cluster Helm charts that are going to be deploying our whole infrastructure for us. Yeah. So that's it. Yeah, we're going to have to edit that file.
Just to show everybody what's inside this demand cluster Helm chart. So just going to clone it, right? You don't need to, but just going to do that, in /tmp. So you can see, what's inside, and just going to show you the, the architecture of how it's built, So yeah, just like this, it looks like this, right? So it's just a few YAML files, and again, thanks Ron, for building this. It's it's a tremendous help, for this small stream that we're doing. So as you can see, you have like a master chart, file at the top. You have also questions. I think it's because Ron is using Rancher to deploy this chart, but we are not using Rancher today. So this is useless to us. But then in the template, you have the admin, the API, and the storefront, and all the configuration that goes with it. And you have a special file here with the values that we can overwrite when we actually, push the whole thing to KWS. To what am I saying? To Kubernetes, to AWS, and whatever. That's said. I'm saying some stupid things now.
Too many abbreviations.
Yeah, too many abbreviations.
Tech is not easy.
Yeah, too many abbreviations in the AWS environment. That's for sure. And we can override these values .yaml, so we can provide our own and set up everything correctly. So what we're going to do is just actually get these values .yaml file, and we will be up and running. So I'm going to change to another folder here. I think I have a stream folder here. Yeah, here it's completely empty, right? I have nothing at all in here, nothing. So let me grab that file. So directly from the repository, I could copy paste as well from my temp environment, but just to show you like the right command, if you can call that right. So just doing a wget, and yeah, I think it's zoomed too much, right? Is it big enough? It's too big, maybe. So wget directly the raw file, from the demand cluster repository, and I get this value file, right? So we already saw this value file earlier in the stream. So as you can see, we have the MongoDB URLs we're going to change, and we have like some blocks. So we have a block for admin, we have a block for API here, and we have a block here for the storefront in here, and we have a block for the MongoDB configuration, which we're going to disable because we are using directly MongoDB Atlas. We don't want a MongoDB cluster to be deployed in Kubernetes for us because we prefer to use MongoDB Atlas, of course. So let's start from the top and go all the way down. So I'm going to zoom. I hope it's big enough. Looks like it. So, Loan, what is Stripe?
Yes. What is Stripe? Well, if you do e-commerce, chances are you probably already know the answer. If you deal with payments in any way online, you've probably already used Stripe, or at least I hope you did, and not another API, because they're really the best out there when it comes to payment APIs. So it's just an API that enables you to process payments. And obviously, we need that for e-commerce. We need that for open commerce. Stripe is the payment processor by default on open commerce. So it will expect an API key for Stripe. But because we're not going all the way setting up a Stripe account, etc., we're just gonna, pass something else. That's not a Stripe key, obviously.
So yeah, we are creating a shop, and it's completely free. So that's cool. You can't pay on it. So we are on top of the e-commerce game. So we are ahead of our times. With loans,
definitely making profit, man. This is gonna go to the New York Stock Exchange next year.
way to be rich, I think. Way to be rich. Oh yeah, and Ron, thanks for confirming what I said. I look smarter, I guess. No, but yeah. So Ron confirmed that the question.yaml file at the top of the repo that we're using is picked by Rancher to give you some form of a form-based questions during the install. So we're not using this. So we're basically answering the form manually right now. So that's what we're doing. Thanks, Ron. So now we need a segment key. What is it?
So segment is an API for analytics. It's not mandatory to have the API key, just like for Stripe. So we're not going to be filling that up. We can just leave it as is, or modify and put whatever you want, but it's not going to be used. So no problem. Yeah.
So again, nope, we're not doing this.
Nope, it's absolutely acceptable. Right. Then we have a secret token here, which is going to be used to for various applications where throughout the infrastructure where we need a randomly generated secret. So you can generate that however you want, but we have a little command that we can run in the terminal to generate a token. It needs to be only digits and letters. It can't be special characters. From my experience, it might, you might find a way to make it work, but usually I found that at least with previous versions in the past, it used to complain a lot.
So we use this OpenSSL round command, and we just generate a random value, and that's going to do for us. Right, next is the MongoDB database URL. So that's my part. So here I just uncomment this and uncomment this, right? So this overrides, the MongoDB URL that would be provided, if it was automatically built in the Kubernetes cluster. But here we want to use Atlas, right? So we're going to use this and supersede, this with our own URL. So where do we get the URL, you might ask? In here. So you go back to MongoDB, you go back to database, and as you can see, our cluster now is up and running, and everything is up. It's 4.4. I didn't do that mistake. And we click connect. In here, we could connect with different things like the MongoDB shell, with our application. So I'm going to go this route, or we could use also MongoDB Campus, which is the MongoDB client that's UI. So you can connect to MongoDB and browse your data and do whatever. And so we're going to use connect application, and I'm going to collect this collection string here. Going back to my file here, just copy paste this here. So I need to change a few things. First, of course, is the password. It's a super safe password. And I need to change the database as well. Here, by default, it's my first database. We're going to overwrite this and say Open Commerce. Retry write equal true, and write concern equal majority. That's super fine. Here, that's what we mentioned earlier. So Meteor is one part of the Open Commerce system, and it's still reading op logs. Today, we are using change streams actually in MongoDB, but this is not up to date yet. But Loan told me that they are going to drop the whole part of the system anyway soon and be replaced by something newer and better. So of course they will be using
it's only the admin UI, which is currently the team is building a new admin UI, which is going to be just pure React and no more Meteor. So this is going away very soon, thankfully.
So we provide exactly the same URL, but we change here the database to local because the uplog is in the local database. So that's just what we need. Next, let's set up the admin. So in the admin, we need to do a few things. First thing is we need to change the host. So we are actually, as you can see, we are publishing like 3 services in our Kubernetes system, right? So the admin, the API, and the storefront. And they all need to talk to each other, right? They need to be able to communicate, etc. And we're going to provide actually like a real host. We're going to host this like on a real domain or actually subdomain, so we can make this work properly. Loan actually used his Outgrow domain name, so we can create a subdomain in his website and host the whole thing there. So for us, it's going to look like something like this. So for the admin, it's going to be admin .open commerce -mdb.outgrow.io.
That's right.
I think it's correct.
And by the way, you need it is correct. And for everyone listening, you need fixed subdomains that you're going to be using for this because you need to know in advance the host of your services, the host name of your services. And it is very important in the setup. We've tried to set it up with the AWS provided DNS names for the load balancers. Every load balancer has a subdomain that's hosted on AmazonAWS.com. And it's like you can reach your load balancer at this address. But for the setup, it really needs to know where it's going to be hosted. So it is very important to have your own domain on this.
Yep. And also it's useful for the certificate, for the SSL certificate for the HTTPS, right? Because the certificate is bounded to subdomains, so we need to make sure that they both match, right?
That's right.
So here, replica count. So if we wanted to deploy like 7 admins, we could totally just put 7 in here, and we would get 7 nodes, right? That's as simple as that to scale up the system. Once you have set up this, with AWS and Kubernetes. So yeah, we're just going to do 1 because we are nice people and we don't want to bankrupt MongoDB like this. Then we have a repository. That's fine. It's a Reaction Commerce admin, so that's just a default image. In here we have the tag. We have everything fine.
So by the way, if you have your own customized version of Reaction Admin, which if you're getting serious into Open Commerce, you will probably have your own customized version of it. You need to reference the Docker repository where it can fetch the Docker image for the admin here. So here we're just fetching from Docker Hub the basic stock image. But yeah, if you have a custom image, this is where you need to change it.
Well, we're going to need to do that, right, Loan? Anyway, we're going to do that for the
So we can use we can use the stock images for the API and the admin, but we still have to build our own image for the storefront. Just because there's some server-side rendered magic that happens on the storefront with Next.js, and it needs to have the right environment values set at build time, where it knows where to reach the API, etc. when it builds. So we're going to have to do that later on. But for the admin and the API, we keep the default images.
Cool.
Now, I think the next step is to set up SSL, but we're going to need to have our certificate generated. So what do you think?
So here it's the ingress, right? And for the ingress, we need to pass some annotations, and those annotations will tell, so 2 things basically. It will tell to the ADL, where is it? In here. So we're going to talk to this AWS load balancer. So the ALB, it's ALB. Too many
load balancer manager. It's not a load balancer itself. Just so that beginners don't get confused.
Yeah. So this controller, we need to basically bind the ingress to this. So this can then create the load balancers that we need in EC2, right? That's basically what's going to happen. So we need to send a small annotation to this so it knows, that we actually expect it to do some work for us. So
we're not binding them to the controller, but just to clarify for beginners, and I'm not an expert, but just from what I understand, it's just that we're telling we're just adding some these annotations to our ingress configuration to let any service know that, hey, we need some load balancers in here. But really, I mean, it could be also any other system that works like this. I'm sure Google has the same stuff, and you can use the same annotations on their GKE platform. So it's really not just AWS specific. From what I understand, it's really just a standard. And it's not just binding to the load balancer controller. It's really just letting the whole infrastructure know, hey, we need some load balancers here. Whoever wants to just go and deploy them.
Right.
Just to clarify for these beginners who join us.
Correct. That's totally true. I'm going to get rid of this. I'm going to put this here. Sorry, I'm just reorganizing a bit my environment so it's not a big mess.
Hey, Ron is telling us that annotations can also be used to do Cloudflare DNS automation, where you can insert the host that you just configured and kind of auto configure your subdomains. That's really cool. We need that, man. Especially I'm managing my DNS for Cloudflare, so we should have done that.
Nice. All right.
That's amazing.
Cool. So next step. All right. I'm struggling with this, but all right. It's just my environment. Sorry about that. Just annoying. All right. One sec. I don't know why I have this here at the top. It's just annoying me. Fix my environment. All right. That's good. So next step. Next step. We need a certificate, right? So let's create this certificate manager here. Create a certificate. It's going to be a public certificate. Click on next. We need a full qualified domain. So for us, it's going to be star dot. Is it? Yes.
Open Commerce -mdb.
Open Commerce -mdb .outgrow.io.
Yep.
And we need also another domain name to make sure that everything works, because that's going to be the IP, the IP address, but the DNS of the storefront, and we're going to use admin.this and API.that, for the two sub parts, for the API.
I'm ashamed to say that, but I don't remember if the wildcard will also match the root domain itself. I mean, it's not the root domain, but like the root subdomain. It might actually match it. I'm pretty sure it might work if we just leave the wildcard, but we're not, as we say, we're not really professionals, so that might not be optimal. Hey, it'll work though, so perfect.
So if this is done, it's good to go. I'm just going to request it, and so now I'm going to wait for Loan, which is the rightful owner of outgrow.io, to accept, this pending validation certificate demand, and it's going to be validated in a minute. And I think you need a couple of things from me, if I'm correct.
Yeah, so I need there's going to be a CNAME validation value here.
Yeah, right.
Well, it looks like it's already, is it already approved?
Is it?
Refresh it.
Yeah, it looks.
It might.
Fine.
Well, I think that it's the same values as before when we were doing our testing. But if you're setting up your own at home and you go for this step, basically you're going to have this CNAME name and CNAME value, and you're going to need to, as a verification, you're going to need to add this to your DNS zone. So pretty standard, like just add that to your DNS zone. Very, very simple. I think that it just kept the same code as before. So I think we're good to go now. Shows green.
Just double check, just in case. I send them to you in the private chat of StreamYard. So yeah, just double check that it's fine. It looks fine on my hand.
No,
it
does. It does match. It does match. It's okay. So we're good to go. I mean, as long as it says green here, then we're good to go. It's just to prove that we have the ownership of the domain. So if it thinks that we have it, then all good.
All good. All right. What else do we have now? We
need to get the ARN of the certificate, I think.
Oh yeah,
which is
right here.
So the ARN, if you're not familiar with AWS terminology, which after setting up an EKS cluster you will be, an ARN is basically an ID for any resource. So you have ARNs for everything. It can be an EC2 instance, can be really anything, and also for certificates. So here we need to get the ID of this certificate and pass it here in this annotation. Certificate ARN. We just need to tell our ingress that, hey, you can use this certificate, and just get it from ACM, and that's it.
Yep.
We also have these annotations for the load balancer. So Maxime, if you want to go over them.
Yeah, exactly. So that's what I was saying earlier. So we are telling basically that it needs to communicate with the I forgot the name again. The
load balancer manager.
Load balancer manager, exactly, to produce. I'm lost. To produce this, load balancing system for us automatically, right, in EC2. That's basically all we need. We are telling it's going to be internet facing at the end. I don't remember why we need the target type IP, but it's just cool. Just do that, and it will just work out of the box. And yeah, so I need to actually copy paste this into like all of them because it's the same configuration for all our ingresses. So I'm just going to go down here and do that 3 times. So in here, copy paste here, and same thing for the storefront. In the ingress, paste this right here, and we are good to go for this.
Yep.
Let me get back at the top, and let's see where we are. So let's review. So admin, we have the admin host, we have the image, we have everything. Oh, and we need the TLS true at the bottom because we're using now like a secure connection with HTTPS. For the API, same thing. We're going to use, so it's api.openCommerce-mdb.outgrow.io. TSL true, I want only one replica. Just for fun here, we can activate the GraphQL playground. I would not do that, of course, in production, but it's fun to do here now as we are, demonstrating the whole product and the whole thing. So we're going to activate here. Of course, don't do that in production, but so we can show you the GraphQL interface that you get. We are not configuring the email server, just like the others. We don't really care about that, but there is this possibility. What else?
Well, we're not initializing a replica set, that's for sure, because Atlas is doing that for us.
Yep. The image that we use for the API is a default one that we get from Reaction Commerce, from the repository. So we just use that. We don't need to touch anything here. The path is true. I already changed the ingress. And I need to change here these to true. So we get the TLS thingy. And at the end, I have the storefront, which is true. Our URL will be, so we said open commerce -mdb.outgrow.io. Here, I need a session secret. So same thing as earlier. I'm just going to generate like a random OpenSSL random value on my other screen. I'm just going to bring it and copy paste. But anything would do, really. And here we will have to change this in a second because we want to use like our custom front end because some IP addresses are actually hard-coded. So we will have to change the repository and the tag. So it means we have to also create a new custom Docker image for this. But you would do that like in a normal deployment of Open Commerce. Correct me if I'm wrong, Loan, but I guess you would be doing that anyway because you want your customized image of the front end anyway.
That's right. I mean, in a real production scenario, you would be just using your own images. You would have your own storefront. By the way, you would probably not even be using the reaction example storefront, because let's be honest, as much as I love Open Commerce, it's not a great storefront. So you would probably be just providing your own storefront, kind of just replace everything you need in there. And your API image would also be different, because you would have some custom logic on the API, some custom plugins and everything. So as Ron says in the comments here, a very good comment on Twitch, he says that in production you would have a CI/CD pipeline running somewhere that would build the containers for you. That is right. So it would just build the Docker images for you, and you would use a reference to these Docker images here in your Helm chart configuration. But here we're just going with the stock images, and we're going to be just rolling our own storefront image, just for the sake of building with the right build time environment variables.
And you also have a comment, Loan. I guess you know.
It is me.
So that's my boy, Loan. Yeah, that's definitely him. He's here.
Mahmoud's a friend of mine. So
thanks for joining. So what's now? So we will replace this in a second. I'm just going to go through and finish the setup at the bottom, which is going to be super easy because we don't need MongoDB in here. So we're just going to say false. That's correct, Loan?
Yep, and that's it. We don't touch anything else.
It's not enabled because we get it like from MongoDB Atlas, right? With the configuration that we did at the top.
Yeah,
so
we just set it to false and then forget about the rest of the it's not going to be using the rest of the configuration anyway, since you say that it's not enabled.
Right.
So yeah.
And so the last thing we need now is a repository with our custom reaction commerce front store. So let's do that right now. So first thing, we're going to go back to AWS and create, so it's the Docker ECR.
Yeah, Elastic Container Registry. There we go.
Right here. Yep. So in the Elastic Container Registry, we are going to create and get started. We're going to create a public because we don't care. We're going to create a public.
You can make it private if you want. If you have your own image with your own code, you're probably going to make it private if you use ECR, but you can obviously use other registries.
I'm going to call it Open Commerce Storefront, and there is no logo, there is no description, there is
this is for open source.
Everything is optional. So
this is for open source stuff. So
create the repository.
This is not going to benefit the open source community, this image that we're building. So no worries.
Definitely. And I can click in here and I can view the push commands. And so we need this now. So basically we need to execute all those commands after we have actually modified and cloned the repository and done our modifications. Then we can upload our own image and use this to deploy then on Kubernetes. Yep. So let's clone now Reaction Commerce frontend. Where is it?
GitHub.com/reactioncommerce/example storefront. Hey, we have Alvaro Bueno from MailChimp joining the chat here on YouTube. He says, thanks for doing this session, and I'll just reply, thanks for joining. It's nice to have you here.
Yeah, thank you very much for being around. We really like and enjoy doing this. We learned a lot actually doing this, preparing this whole session. We're not going to say that we did it yesterday and it was actually kind of a challenge, but yeah, we are happy that we are sharing our new knowledge with the community. So yeah, and thanks for being around. So next step, so example storefront. I'm just going to clone this, and as you can see somewhere in here there is a Docker file that I can't see. Docker file right here. So it's already set up for us. All we need is do our modifications and build the whole thing, right? So I'm going to go in the code, copy paste this. And so I'm going to save this file here, which is right here. I'm just going to clone this right next to it. So git clone this. And so the only modification that we need to do in the example storefront is in the .env production file. And we need to change those default APIs. They will get wrong, by default because it's binded to localhost and everything.
So this is used at build time. This whole this whole end file. So you might be wondering, why are we setting up production environment variables for deployment on an end file that we then we build the image and then I imagine that it might be very confusing at first. Actually, this is just for build time. So Next.js will generate. So it will render stuff for us on the server side, and it will generate static content from our pages and our React components, and it needs to know where to reach our GraphQL API, etc. at build time. Now our API is not yet deployed, so at build time it's just going to reach nothing, but at least it's going to have the right values in there, which is important to run it properly. So obviously then when you make updates, you're going to have your API running, and you can just build it against the live API, which is what you're supposed to do. And actually, if you're serious about Next.js and you want to keep this Next.js storefront, you might as well deploy on Vercel actually, and not deploy on your Kubernetes cluster. I would really advise you, this is not something that we did, but I would really advise you to just use Vercel. Makes things a lot more easy for you. It will do all of that for you as well, all of the build time stuff, etc. Just Vercel is the platform as a service product from Next.js. The people behind the Next.js framework. So I would just use that, to be honest, and just not use Kubernetes, and just keep the API in the admin on Kubes.
Yeah, well, I guess if you do a real production, system, I guess you would also need to change, those values here and put something more serious than, under a key here. I guess that would be recommended as well. But for us, we just, we are doing a minimalistic, production environment, so that's just going to be good for us. So I'm just going to save this, and that's all we needed to change actually for our, super custom front end. But just so you see the concept, and how you would be doing that, for your own system. So now that we are done with this, I can just build the whole thing. So I'm going to just go back here and take the commands, from AWS. So first, I need to log in to this repository that we just created earlier. So I'm just going to log in like this, and login successful. I'm going to build the image, which is using some cache that I had already, which should be fine, I hope.
It's been a while that I haven't used the example storefront, and I hope that building it against an API endpoint that is not yet live, I hope that's going to be fine. I hope it's not going to give us too hard of a time on this. But let's see. It's part of the joys of doing it live, I guess.
And in the meantime, while it's building, have a look to the chat. Of course, if you have any questions, please feel free to ask any questions, whatever. It looks very, very red. That's completely normal. Don't panic. I'm not panicking. Do you see me panicking? I'm not panicking.
Just some pure. Is it really a JavaScript project if you don't have pure dependency warnings at build time?
Of course, but it's completely safe. But use an adult, in production, right? You use, some kind of, somebody with a brain. Don't call us, please. So, and we have Francisco, from Dominican Republic, So this stream is really growing like we are worldwide now. We are so famous. We're in the Dominican Republic. I'm actually amazed. Thanks a lot for being around.
That's what I'm talking about.
Yeah. And just so you know, we are actually live, so I'm in Paris and Loan is actually in Dubai right now. So we are actually like all around the world right now. So I'm actually amazed. Thanks for being around. Ron, what are you saying? What did we do? Did we do something wrong? So he says, insert this in your bin directory and run it in your workflow to do this management for cluster. And then he says the gist copies of the environment storefront, since storefront only works from file. Yep.
Well, looks like there is a better way to do that. Yeah, I mean, this is really just a minimalistic setup, right? It's not meant to be perfect. But I guess that solution, I don't really see how that works in practice. I'm not sure where that bin directory is, and where you can run that in your workflow, etc. Not exactly. Oh, run. Do you mean like inserting like secrets, etc., into that file at build time or something like this? But I guess we'll see when he replies. But yeah, there are better ways to do that for sure. We're just kind of doing a demo. Well, I saw some red there, so it was unable to reach the API. Obviously, let's see if the image is broken when we run it. Yeah, that's what matters. It should still run from. It should just not have any content that's server-side rendered. But
if it doesn't work, that's because of that. But
let's roll with it. It's not alive without some surprises on the way. And we've we've been asking for it, right? I mean, we should have tried this before.
Yeah. Well, we need some, unsafe place, to do that. Like, let's not do this live, right? So we can edit it, right?
It's not fun if there's no if everything works on the first try. It's not fun, We gotta be failing live in front of an audience.
So the build is done. Now I should be able to tag that image. That's probably not broken. And now that it's probably not broken, I can push this to our public repository in ECR. I have a kick-ass internet connection, so it should not take too long.
I can see that.
That should be done in a few seconds, right? So it's uploading the image, and then it should be able to be used in our build.
I'm low-key jealous of your fiber connection. It's amazing.
Yeah. Internet cables, no Wi-Fi. That's the trick.
Everybody. You don't use Wi-Fi? That's smart. Well, I should be doing that.
Just for my phone, because
But if your modem gets 20 megabits per second, you're not going faster with internet. So that's right. My problem. That's my problem.
That's right. All right. So it looks like we are about to be done with the push of the image. Manuel says weird flex, but okay.
Yeah, nerd flex, I guess.
Nerd flex, yeah. Internet connection, 1 gigabyte.
All right.
Fiber. All right, cool.
Looks like it's pushed.
Done here, and I think we are almost done.
Do you want to go on AWS and show us that it's been pushed? We should see it here.
So if we refresh this, it should be here now. So we have the latest. That's super cool. If I click here, I should be able to actually retrieve this. I need this, right?
Yeah, but just get the one from your command line, because you have it with the. Oh no, you don't need it with the tag. No, it's fine. Just get that one. This one.
I think that's not what I need in the value.
Yeah. But there's a notation where you just append the tag on the same string, but I forgot. It's not what we need. So we're fine. Just paste what you have there. That's perfect.
All right. So that goes there, right? We'll get rid of this.
Remove the latest, and you use latest here. Yeah. All right. Should be good. Let's give it a final check. I think our values, the YAML is finally ready. Can you believe we spent like more than half of the stream just building this file?
Yeah, but then it's all just one command. That's the magic of Helm, and that's what we want. So in theory, we are ready to go. We have MongoDB URLs at the top. We have some random values and token secrets. We have also the ingress that is configured correctly with the the load balancer controller, which is going to create the load balancers for us in EC2. That's what those lines are about. We have the certificate as well that we generated that is attached to this URL subdomain. So we should be all good. I think we are good across the board.
Yeah, and if we're not good, we'll know soon enough.
Oh, yeah, for sure. All right, so let's try this in production now. So I need to find my secret command to run this. Where is this now? All right, I can't see with my mic in the middle. So where is it?
I think you can even write it. It's pretty simple. It's helm install helm install Open Commerce, and then you have domain cluster /Open Commerce or something like this.
Yeah,
double
something
dash
like
values,
this.
double dash values equal values.yaml. I think something like that.
Here, boom, moment of truth.
There we go.
All right, so Helm install Open Commerce, which is just the name we give to our installation. Can be anything. We have, we forgot something before that, actually. We forgot to say that we need to add the repository. Where is it?
So we've already done that, but you would need to do it on your machine.
Exactly, yeah. So you need to do this command first. You need to add run repository first. You need to do Helm repo add demand cluster
and run. And I think Ron just has pity for us, and he just sent us the Helm install command in the chat on Twitch.
That's right. So the command is here. Like if you're wondering, that's definitely the one.
All right, next time we should just have Ron on the stream with us. That would be a lot of fun.
Oh, directly. He must be so pissed, seeing me typing so slowly and failing so hard. So yeah. All right, so you type this command. If you want to update it, because maybe Ron pushed some new updates, I think you need to do like Helm repo update, something like that. Yes. Yep. So Helm repo update. I hope you didn't change anything, Ron, in the meantime, and won't blow up this presentation. Else I'm gonna totally put it on you. And finally, we can finally run this command that is broken now. God damn it.
You have it in the chat. Look, you can just copy paste from Ron's message.
Got it. Boom. So now we praise the God, the new gods and the old gods, and well, I'm gonna say it says congratulations, right? So that's already a win, right?
Yeah. But then will the pods actually start? That's the question. So now we can check it with kubectl if you want to run that command.
Yeah. So I have the command already ready. So kubectl pods all namespace wide.
Yeah, we don't need all namespaces, but it's like kind of gives you also the system ones.
Yeah, just to see the whole system. It's kind of small, but if I zoom, it breaks the whole thing. So
does it say running on all of them?
Yep, it's all running. It says running everywhere, 1.1. So as you can see, we have all the kubectl different services here running. We have two AWS load balancer controllers. We have like the nodes, the core DNS, we have the proxy, and now we have those 3 new machines. Ron says, yay! Yatta! Yeah, we'll see if it actually works. Don't panic. Maybe it's actually not working at all, but we'll see that in a sec. Actually, the first thing I need to do now is check the ingress as well. So there is also this command, kubectl get ingress -a.
And they should get the DNS from the load balancers that are assigned to them. That the load balancers that are going to pass the traffic onto the ingress. So we have the addresses right there. You can see they've been assigned an Amazon AWS.com DNS name. So that's a great sign. It means that we have our load balancers that were just created out of thin air like magic, which is amazing. So I'm just going to go and link my, I'm going to reference these in my DNS zone on my domain. So I'm not going to show that. But basically, you would use these, for the admin, the API, etc. You would use this AWS DNS name here, and you would create a CNAME for your subdomain. So for example, like api.yourdomain.com, you would create a CNAME for API, and then the value of the CNAME would be that URL that you see right here in your kubectl get ingress-a command. It will give them to you straight from the CLI, which is pretty handy. So yeah, just gonna do that right now. Just bear with me a second. You know how updating DNS zones is not always the same. The most painless experience. So I'm just doing that. Already done the admin. Now doing the API. Once again, you can't see it. That's just because I'm not going to show you my Cloudflare, admin panel, but you would do the same for your domain. So I've done the API, and now onto doing the storefront. And man, I'm I'm just very curious to see what the storefront will look like since we've built it against an API that was unreachable.
I'm gonna hit this if that doesn't work, but
it might be broken, but it
yeah.
might as well. You know, it theoretically should work, but
We'll
let's see. You know, it never works as intended usually.
So let's have a look to while you're doing this. You know, let's have a look to
I've done it. Sorry,
EKS again. Done. Okay, so then while the DNS are propagating, and you know, so we make sure that everything works. So if we go back to the EKS now, we have our open cluster. Open commerce cluster. We still have our 2 nodes. If we check the workload, we see the pods, just like we just saw the pods. So now we have like 3 new
workloads
services, in here. So the admin, the API, and the storefront. We also have, if I go to AWS ECS, if we I'm expired again. All right, just gonna go here. It was not ECS actually. If I go to EC2, I see all my machines, a lot of things running. That's my network actually. So we have our instances and a few others that actually stopped. I should have another one in here. I don't know where it is, but yeah. And in here we have the load balancers. And in here we should have a couple of lines. Yeah. So here we have like the 3 lines. They're already alive and active. So here you see that it was already automatically created for us by the load balancer controller that we have in our Kubernetes cluster, right? So that's what he has been doing. Because we provided the right annotations, he created those load balancers for us, automatically set up correctly. And Loan just finished the last part, which is link this to the actual subdomain in outgrow.io. That's correct? I said that right?
That is correct, yes.
So now I think the last part is a moment of truth. Is this whole thing actually running? Is this actually running?
Let's find out.
Let's find out. And
maybe we can start with the API, you know, since it's kind of the founding block of everything. We can start to see if we have a GraphQL playground on there.
So URL API, it's actually https://api.opencommerce/GraphQL at the end. And oh my God, it works.
Amazing.
We can also confirm that it's working by going to MongoDB Atlas. And we can already see that we have some activity on the node, right? We see that something definitely is happening here. We see some connections. So we see some stuff. So it looks like it's also working here. If I browse the collections, that's the brand new cluster we created earlier. We should see like all the default collections, you know, from Open Commerce in here. So you see like the accounts, the catalog, the card notification, order, product, whatever. You see like all the stuff, the internal collections, you know, of Open Commerce. So it looks like we have definitely some kind of connection. So that's cool. Let's see if we have an admin console.
Yeah, so we're going to need to create our admin account. The first account that is created is going to be the one that gets owner rights. So be careful about the first account that you create. And then you can create your,
right.
You can create your shop there as well.
Yeah, let's create all the things. So create an account. So let's say Maxime at localhost.com. This. Nope. I create my shop. Maxime's shop. Create my shop. And cool. I have a nice shop.
Create a product.
What else do we have? We can create a product. So let's create a product. In a new product, I'm going to sell, what can I sell? I'm going to say some memes, right? I need a random meme. I'm going to sell this meme. So I'm going to save it. I'm going to say meme 1.
This man is reinventing NFTs right here.
So take my money. What's in here? We have a country of origin that's definitely come from Argentina. We have some, well, we don't care about all the things, to be honest. So I'm just going to save the changes. Oh, where is the image? That's my image. Meme 1. Cool. Here we have make visible. Here we have, so can you explain this? So that's one of the variant, of the meme, right? That's one of the variant of the product. So if I was selling T-shirts, like I can have like a red one, a blue one, and a gray one, right?
That's correct. Yep. So you would list all of your variants there. You can have multiple nested levels. You can have variants have different prices, etc. So and you need at least one variant for each product.
So let's create one random product. So that's my meme. That's a size. I don't know. This is my short meme, the short one, and it's definitely coming from Benin. Of course, I sell this for $100 only. That's a bargain. I have, of course, an inventory for this.
Don't forget to save on all of these blocks.
I think you can save. Oh,
no,
blocks, right?
It's not the best UX, man. It's
I actually lost that already. Damn. All right.
Yeah, you're supposed to save when you're done, man.
All right. Title, the small one. It's coming from Bahamas now. Save changes. Looks good. Looks like we have everything we want. Do I need the picture again? I don't know. We'll just put a picture again. That's my short meme. It's saved. Here it's hidden. I'm going to make it visible. I'm going to hit public. And so now I should be able to go to the.
I think you need a tag. You need a tag, I think, no?
No, looks like it's here. It's online.
Amazing. Look at that. Perfect.
I have my shop. Now you can shop for my stuff.
Perfect. So it's not the most beautiful storefront, as you can see. There's even some styling glitches, etc., that are due to a style rehydration. That's a topic that I don't want to get into. But when you use Open Commerce, you're really supposed to just build your own storefront, and you can see why. Because who would want to deploy this to production? But at least it works. There's an add to cart button, and you have the cart flow. You have the checkout flow, etc. You can create a customer account. You have tags, for categories and all of that. But really, you would not be using this storefront in production. In reality, the whole point of Open Commerce is the API, and then you build whatever UIs you want on top of it. But hey, it works amazingly. It works amazingly well. First try, man. It's unexpected.
First try. I'm actually surprised at our little trick, with the unreachable API when we build the front end actually worked, but it looks like it's working, so that's pretty cool. We can explore the GraphQL API a bit, maybe, like the primary store. We can actually retrieve the primary store like this. Like I had a query saved already. Yep. So you have the ID, the name, the language, whatever. As you can see, like we can retrieve Maxime shop here. We can retrieve our product, maybe. Can you show me how to retrieve the product?
Yeah, so it's a bit complex, but you would first of all get the primary shop ID, because we need to. So you can copy the ID that you see on the right here, because we are going to need to have this ID referenced. And I think there's a double equal at the end, so you need to copy that as well, or like the whole string, basically. It's a base 64 ID, so you're going to have this equal at the end. So for the query, you have two queries. For products, you have the product query, which is not what we're going to be using, because that's a query for the admin, which is going to give you even like the draft products and all of that. So that's not what you're going to be using for the storefront. As a customer who's not authenticated as an admin, you're going to be using the catalog items query. So you have the products collection, which stores everything, including the drafts, etc. And then you will have the catalogs collection, which catalogs with an S or catalog singular? Oh yeah, singular, I think. Catalog up there, yep. Catalog collection stores, a much more optimized object-minded, structured data, where you have all of the variants inside of the same object for performance. So it's much better than just doing lookups, etc., which is not really something that you want to do too much when it's not needed on MongoDB. So with the catalog collection, you just have for one product you have all the variants, etc., in the same object. Just makes performance much better. So our catalog item GraphQL query is going to fetch from this catalog collection, basically, which is different. Once again, different than the products collection. So let's go back to the GraphQL playground, and we can just write the catalog items query if you want, Maxime, or want to dive more into the database, maybe.
No, up to you. It was just going also through the database, just to show that you can actually browse, directly in MongoDB Atlas the collections. You can already explore, have a look, and you can edit, copy. You can manipulate the data also directly in here.
That's really handy, especially when you have a VPC Pairing connection and you have not opened your MongoDB cluster to the outside world. So if you don't want to whitelist your home IP address or office IP address, maybe you're on you might be on a public Wi-Fi or something. You don't want to open the whole IP on your cluster. You can just go on your browser, and you don't even need to open your local MongoDB client. I love this feature. I use it all the time, to be honest with you.
Right. So you want to have a look with the API?
You can create query catalog items and
is it uppercase C?
No, lowercase c. Well, it doesn't matter for this query name, but let's just make it proper. Catalog items with a capital I, and then you would just open your brackets, and then catalog items once again, same casing. Yep, and then you can pass it some. You can pass it. You're going to pass it some input variables. So you can open some. Brackets there. Shop IDs is the one we want to pass. So it's going to be an array that includes our one and only shop ID. Yeah, it needs to be an array. Perfect. I'm not quite seeing close enough what you're doing here. No, it's not an equal. It's you need to use a colon, right? Put a space for good measure, and then is that enough? Actually, I don't know. Let's find out. So then you can use nodes, not edges, because edges is going to be for paginated. Might not have page info actually. Just use edges. Nodes. Sorry, nodes. I'm just confused. Nodes, and then you need to use a subfield. So for example, you can you can use a title, which is sorry, go into product. Grab the ID maybe. Grab the ID, and then you just print that. Yep, perfect. Look, so we got the ID of the one and only product we have. And then if you want to dive deeper, you can use product inside of that query here. So might want to break a line actually, so within the curly brackets as well. Yeah, just to keep everything clean. Product. You should be able to query product here, as far as I know.
Be through the shop first, no?
Sorry, it just if you write title, what and that's the part when the self-documented schema comes in handy. So if you want to go to schema, right? And then you can command F catalog items, and it will. I think it will just tell you that it will return to you a type catalog item node or something like this in the nodes. So if you scroll down, it's a bit complicated. You have a lot of options. As you can see, you can do filtering and all of that. Mm-hmm. Catalog item connection. And then if you go and see catalog item connection, it will tell you that you have the edges and the nodes. So you can search catalog item connection maybe.
Catalog item connections. Where is it?
Yeah, connection is at the top here. If you don't scroll, just go the first line that you have. It's what's being returned by the
To this, right?
No.
I'm
Just two lines above this. Catalog
This.
item connection. No.
Oh,
The
this.
one line.
Okay.
Right, look, yeah, this one.
Okay.
And you no. So don't put that here. This is the type that's being returned by this query, and it contains the nodes and the edges, and we're going into the nodes, right? So we need to know what type the nodes are, and then within that type, we're going to see, like what we have available. So search for catalog item connection, like Command F or Control F. Sorry, I have my Mac user habits. All right, so here we see we have edges, nodes, and page info and the total count. So we're going to be, so now you can see that we're using nodes here. So we're going to be looking at the catalog item type. So if you want to Control F for catalog item here, I don't know if we're going to have edges because we don't have any variable inputs for pagination. I don't remember quite how that works. So catalog item, so we have an interface here. And I think it's being extended somewhere. Actually, it might be a little bit. Yeah,
it looks like there is a shop date.
Yep.
Anyway, it's for sure we can explore this, right?
We should be able to do product, and then within product, so product, and then curly brackets, and then we should have the title, actually. From what I remember, and if someone can tell us otherwise in the chat, actually, it's kind of comical because I'm the one who's been using this Open Commerce API for like 5-6 years now, but for some reason, just I'm having a hard time here.
It's Sanji's as well, I guess, right? So yeah, it's not a big deal, right? So the GraphQL API definitely works, right? So like the whole thing works. I'm actually really happy that we were able to make it work. So that's super cool.
Especially first try.
First try. So I'm really pleased that we made this work. Is there anything else you want to demo in like the front part maybe? So
honestly, I mean the whole thing is so complex. I mean, in terms of all the features that it has, Open Commerce is really something that needs a whole demo on its own. And I think that if you want to dive deeper into it and kind of play with it for yourself, there's actually you can actually set up a development environment on your own machine pretty easily. We have a repo for that. Maxime, maybe you can open it in the GitHub organization for Reaction Commerce. We have a repo where we have a makefile, and the makefile will set up all the Docker containers for you on your machine. So if you want to set that up, and kind of play with it, you can do that very easily. So the repo is called the Reaction Development Platform. So it's right there. Yep. And you can see we have a makefile, and the makefile will do everything for you. So it's not perfect. You might have some trouble, but we actually have a Discord channel that is for the community. And, everybody, including Ron, myself, Alvaro, we have also Akarshit and Mohan from MailChimp. Are just helping the community over there. So if you have any problems, you can just go on Discord and reach out for help, and we're always happy to help if you have any issues. But if you're running Windows, you might have some trouble running that, just like any Docker setup. If you're on Linux or Mac OS, then you should just be fine running that makefile, and you can just play with it for yourself. If you need an API first e-commerce platform, that's a pretty damn good choice. So that's all I can say.
Cool. Wow. That's all good.
Man, I was expecting some failure at one point. So I'm surprised of this success.
It failed so much when we were trying to set up this. Like we redeployed this like a million times, and we can actually show you like how easy it is to also like remove this and redeploy this. Like basically, you just need to type this like Helm delete Open Commerce. Just type this, and everything's gone. Right? The data is still here because we are running MongoDB Atlas, so like we haven't touched the database. So like if we decide to redeploy this with like 12 nodes now, because we are reaching some major deals, whatever we are reaching new heights, then we can totally just change and edit the Helm file. the Helm, the YAML files, edit how many replicas we want, and just redeploy this. And to redeploy, no, it's just one command. I can just redeploy this, and it will just work the same, right? So we will need to redo this, rechange the addresses here in the DNS of Loan, but we won't do that again. But that's really as simple as that. Now we can just summarize the whole stream to these two commands, right? Just delete and install, and it just works out of the box. So we've done all the setup now, so like this works, and you don't need to do that ever again, basically. So
the thing is, if you have a Kubernetes cluster, and it might not be in EKS, actually, it can be on anywhere, even on your own servers, whatever you want to use. If you have a Kubernetes cluster that's running, you can run Helm install whatever, and it's just gonna install on your cluster. So that's the beauty of it, right? Once you have the cluster running, and obviously you need the right values to pass to your Helm chart, but that's pretty much it, right? That's all that's, it really simplifies, because Kubernetes is extremely complicated, and we've maybe we've used like 1% or 0.5% of its capabilities today. Actually, maybe less than this. But Helm actually really simplifies things for you. So really the biggest part of the job is getting the cluster up and running.
And as you can see now, like everything is back to normal. Everything is up and running again, like in just a few seconds. While Loan was talking, it's just back up and running, and everything was recreated again. Like the load balancer controller recreated the load balancers for us. Like everything was just redone from scratch, basically, like in just a few seconds now. So that's basically what we wanted to present you today, and how easy it is to do once you've done all the setup and you've been through the whole trouble of setting the certificates and the repository for Docker and all the things. Know that it's done. You don't need to do that ever again, basically, and you're good to go and redeploy as many times as you like on as many servers as you want. That's basically it. So I think we're going to wrap, right, Loan? I think we've been through...
that's a huge success. I don't think we have anything else to say. Maybe if anyone has questions on the chat, because we haven't had many questions. But I think if we don't have any questions, maybe in a few minutes we can go offline.
Yeah. So I think we've presented everything we wanted to present it. We've been through. We can summarize a bit, but we've been through like many AWS services. Just to mention a few, I don't know if I can actually see my services easily. Yeah, here. So we use basically all those services to make this work. Right? So we use the Elastic Kubernetes service. We use EC2 because we have two machines running in there, and as well as the load balancers. We have the Elastic Container Registry for the Docker container we created for the store front end. We have the SSL certificate managed by the certificate manager in AWS. We use the VPCs to connect the peering with MongoDB Atlas. So our connection between the VPC that's running the MongoDB Atlas cluster is connected to the VPC that Kubernetes is running for us in AWS. We can use CloudWatch, for the logging system. We use YAM as well because we have the YAM policy and the YAM service
account.
Service account. Thank you. That's required for the load balancer controller. I think I summarized everything. But yeah, we use all those services in AWS. I have to say that the AWS doc was pretty impressive to drive us through this. And we started maybe a day or two ago to work on this, and it was completely, I would not say trivial to do, but the doc really helps us. So it was really great.
Yeah,
and
hopefully this video will help you as well, because we're just beginners trying to help beginners as well, and if it can help you understand better, then it's a job well done.
Yeah, if we've done something wrong, if you see something that can be improved, like we missed maybe something, just reach out to us as well on the social media. I can bring back the slide deck. I don't know where it is.
We have a thank you slide there. I think we can use.
If I find it. If I find it, it's somewhere here at the bottom, I guess.
Yep, it's the last one.
Yeah, that one works as well, but we are the thank you part, so definitely do that.
Yeah.
Yeah, so you have my handle here on Twitter and you have Loans on Twitter as well. You can also 2 more things before we say goodbye. Three. Let's say 3. So just to remind you, you have the MongoDB local London event that will be held on the 9th of November. So it's really soon. I will be there to present a talk about REST APIs and GraphQL with MongoDB Realm. That's the serverless platform that's living on top of MongoDB Atlas clusters. So I will present this there on the 9th of November. Another thing that you don't want to miss is the developer hub of MongoDB. It's developer.mongodb.com. And in here, you have a bunch of blog posts. I will probably create one about what we've done today with Loan. And like you can visit, in here, you have like a lot of technical stuff. Like the stream is actually right here somewhere, or it will be when it's actually published. Can we actually see it now? Yeah, it's actually here. Deploy an Atlas cluster. Yeah, that's us. So like everything is in here, as you can see, like Twitch streams, articles, videos. We also have podcasts. So if you want, you can listen to the MongoDB podcast. And finally, if you have any questions, that you need some help, whatever, with your MongoDB beauty stuff, whatever you're doing, you can ask the question on the MongoDB community forum. I'm answering a lot of questions there. You can ping me if you like. You can find me easily, and you can ask questions about pretty much anything. As you can see, we have a bunch of topics from MongoDB University to MongoDB Atlas to MongoDB Realm. If you didn't know, we also have the MongoDB University where you can learn everything about MongoDB. We have free courses you can follow for free. That's in the free name, I guess. Where are the courses? Find the course. Here you have all the MongoDB courses. Well, I think I said it all. I don't know what else to say. I think I've been all around the place. If you go to MongoDB local London, there is my code. Beugnet 75. You can get 75% discount on the price of the ticket. So I guess it's almost free when you remove 75%. I think it was not even expensive at the beginning. I guess it's going to be more expensive for us to pay for your food than anything else, but so basically it's almost free to get there. So join us, have some fun with us. You can meet all the experts, in the expert booth that you have in the main hall, and me on stage. So, yeah, that's it. Loan, do you have any other final word you want to share, maybe?
Well, final words, that makes it sound like something bad is going to happen to me. No, not many final words. I mean, thank you, Maxime, for having me. It was a pleasure. I hope that this stream was helpful to you guys in the chat. We don't have many questions or anything like this, so I will assume that everything's clear for everyone. But as Maxime said, if you have any questions or any comments, or if we did anything wrong, reach out to us on Twitter. You have our handles. So thank you very much, Maxime, for your time.
Yeah, thank you very much, Loan, for being around as well. I know it's a bit later as well for you in Dubai. So thanks for sticking around and for meeting meeting the deadlines and everything. So yeah, it's really cool for you to be around and just being here on the stream. It's really a pleasure. So yeah, thanks everyone. Thanks for everybody who stick and you've been amazing around all the chat. Thanks Ron as well for providing the charts that we use.
Yeah, special thanks to Ron and Demand Cluster. You guys have really made our life so much easier here. So
he's
really
definitely the little genius behind all the magic we've been doing today. So yeah, thanks a lot. Yep. Really appreciate it. Thanks a lot, everybody. See you next time.
Bye.